Let's investigate the possible causes and troubleshooting steps for a 120/208 volts, 3-phase, 4-wire panel with a 150 amps main circuit breaker that trips after about 30 minutes of operation, specifically when the lights are turned on. The initial readings show phase currents of 50 amps, 70 amps, and 42 amps, with a neutral current of 16 amps. Firstly, consider an overloaded circuit. The total current draw from the lights might be exceeding the ampacity of the 150 amps main breaker. Secondly, investigate loose or corroded connections which can increase resistance and cause overheating, ultimately leading to the breaker tripping. Thirdly, examine the possibility of a short circuit between the phase conductors, or between a phase conductor and the neutral, as this can cause a high current flow and trip the breaker. Fourthly, think about a ground fault. A ground fault can occur when current leaks out of the system through an unintended path, causing the neutral current to increase and potentially trip the breaker. Fifthly, it could be due to faulty electrical devices. A faulty light fixture, ballast, or other electrical device might draw excessive current and cause the breaker to trip. Now, let's discuss the troubleshooting steps to identify the root cause. 1. Inspect the electrical panel. Look for any loose or corroded connections, burnt or damaged wires, or tripped circuit breakers. Tighten any loose connections and replace any damaged wires that appear compromised. 2. Verify the circuit load. Calculate the total current draw of all the lights connected to the affected circuit. Make sure that the total load is within the capacity of the 150 amps main breaker. Use an appropriate clamp meter to measure the current on each phase conductor while the lights are operating. Compare these measurements to the calculated load to identify any discrepancies. 3. Check for short circuits. Use a continuity tester to check for shorts between the phase conductors and between the phase conductors and the neutral. Any detected short should be repaired immediately by a qualified electrician. Disconnect the power before performing continuity tests to avoid damaging the tester or creating a hazardous situation. 4. Identify faulty devices. Turn on lights one at a time and monitor the main breaker. If the breaker trips when a specific light is turned on, isolate the faulty device and repair or replace it. A process of elimination can help pinpoint the problematic fixture or ballast. 5. Test for ground faults. Use a ground fault circuit interrupter, or GFCI tester to check for ground faults. If the GFCI trips, there is a ground fault that needs to be located and repaired by a qualified electrician. Ground faults can be difficult to trace, so professional assistance may be necessary. Further considerations include the type of lighting used. Fluorescent lighting can have high inrush currents when turned on, which can temporarily increase the load in the circuit. This initial surge could be contributing to the breaker tripping. While LED lighting typically has lower inrush currents, the driver circuits can still draw some current. Moreover, harmonic distortions can be a factor. Nonlinear loads such as electronic ballasts and LED drivers can generate harmonic currents that can increase the neutral current and potentially trip the breaker. Harmonic currents are multiples of the fundamental frequency, such as 60 Hz, and can cause issues with electrical systems if not properly mitigated. To address harmonic distortions, consider using harmonic filters or reactors to reduce their impact on the electrical system. An important note about the neutral current. A neutral current of 16 amps might indicate an imbalance in the phase loads or the presence of harmonic currents. Ideally, in a balanced three-phase system, the neutral current should be close to zero. Significant neutral current can overheat the neutral conductor and potentially damage the electrical system. To mitigate this, try to balance the loads across the three phases as much as possible and consider using equipment with low harmonic distortion. When calculating the load, consider the ballast factor for fluorescent lighting. The ballast factor is the ratio of the light output of a lamp operated by a specific ballast to the light output of the same lamp operated by a standard reference ballast. This factor can affect the actual current draw of a lighting circuit. Also, consider the ambient temperature. High ambient temperatures can affect the ampacity of conductors and circuit breakers. If the electrical panel is located in a hot environment, the breaker might be tripping due to thermal overload. Ensure that the panel is adequately ventilated to prevent overheating. In addition, be aware of nuisance tripping. Sometimes, circuit breakers can trip for no apparent reason due to manufacturing defects or internal component failures. If all other troubleshooting steps have been exhausted, consider replacing the main breaker to rule out this possibility. However, it is recommended to consult with a qualified electrician before replacing any electrical components. Safety is paramount when working with electricity. Always turn off the power to the circuit before performing any inspections or repairs. Use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it is best to call a qualified electrician. When measuring current with a clamp meter, make sure to clamp around only one conductor at a time. Clamping around multiple conductors will result in inaccurate readings due to the magnetic fields cancelling each other out. Also, ensure that the clamp meter is properly calibrated to ensure accurate measurement. When checking for loose connections, use a torque screwdriver to tighten the connections to the manufacturer's specified torque. Over-tightening or under-tightening connections can lead to problems. Periodically inspect the electrical panel for signs of corrosion or damage. Corrosion can increase resistance and lead to overheating, while damage can compromise the safety of the electrical system. Clean any corrosion with a wire brush and apply a corrosion inhibitor. Repair any damage promptly to prevent further issues. Consider the age of the electrical system. Older electrical systems may have outdated wiring and components that are more prone to failure. If the electrical system is very old, it might be time to consider upgrading it to meet current safety standards and accommodate modern electrical loads. When working with three-phase power, it is important to understand the phase relationships. The voltage between any two phases in a 120/208 volt system is 208 volts, while the voltage between any phase and neutral is 120 volts. Ensure that equipment is properly rated for the correct voltage to prevent damage or malfunction. If the lighting load has been recently changed, for example from fluorescent to LED, make sure that the electrical system is properly configured to accommodate the new load. Different types of lighting have different electrical characteristics, and the existing wiring and circuit breakers might not be adequate for the new lighting. It's also important to consider the impact of voltage fluctuations on the lighting system. Voltage fluctuations can cause lights to flicker or dim and can also damage electronic ballasts and LED drivers. If voltage fluctuations are a problem, consider using a voltage regulator to stabilize the voltage to the lighting system. Also, consider the use of surge protection devices, or SPDs, to protect the lighting system from voltage surges caused by lightning or other electrical disturbances. SPD can help prevent damage to electronic ballasts and LED drivers, and can also improve the reliability of the lighting system. If the tripping problem only occurs during certain times of the day, for example, during peak demand hours, it might be due to voltage drops caused by excessive load in the electrical distribution system. In this case, consider reducing the lighting load or upgrading the electrical service to provide more capacity. When inspecting the electrical panel, look for signs of rodent or insect infestation. Rodents and insects can damage wiring and electrical components, and can also create fire hazards. Seal any openings in the electrical panel to prevent pests from entering. Also, be aware of the presence of flammable materials near the electrical panel. Keep flammable materials away from the panel to prevent fires. In a Nevada location, be especially mindful of temperature fluctuations and potential dust accumulation. These factors can affect the performance and longevity of electrical component. Regular maintenance and inspections are crucial to ensure the safe and reliable operation of the electrical system. Keep a record of all inspections and repairs, and follow a regular maintenance schedule. Finally, remember that electrical work can be dangerous. If you are not qualified to perform electrical work, it is best to call a qualified electrician. A qualified electrician has the knowledge, skills, and experience to safely and effectively diagnose and repair electrical problems. Consulting with a qualified electrician is always recommended to properly diagnose and resolve the issue with the tripping main breaker. They can perform a thorough inspection of the electrical system, identify the root cause of the problem, and recommend the appropriate solution. Attempting to repair electrical problems without proper training and experience can be dangerous and can lead to serious injury or property damage. Always prioritize safety when working with electricity, and consult with a qualified electrician if you have any doubts or concerns. Remember to review the National Electrical Code, or NEC, for relevant guidelines and regulations. For example, NEC Table 310.15b16 provides ampacity ratings for conductors based on insulation type and temperature rating. This information is essential for ensuring that conductors are properly sized for the intended load. Also, refer to NEC Section 220.12 for requirements for calculating lighting loads. This section provides guidelines for determining the minimum lighting load for various types of occupancies. In addition, be aware of local electrical codes and regulations which may be more stringent than the NEC requirements. Always comply with all applicable codes and regulations to ensure the safety and compliance of the electrical system. When troubleshooting electrical problems, it is important to have a systematic approach. Start by gathering information about the problem, such as when it occurs, what happens when it occurs, and what has changed recently. Then perform a visual inspection of the electrical system, looking for any obvious signs of damage or problems. Next, use appropriate test equipment to measure voltage, current, and resistance. Finally, analyze the data and draw conclusions about the root cause of the problem. By following a systematic approach, you can efficiently and effectively troubleshoot electrical problems and identify the appropriate solutions. Remember that electrical systems are complex and interconnected, and a problem in one part of the system can affect other parts of the system. Therefore, it is important to consider the entire system when troubleshooting electrical problems. Also, be aware of the potential for cascading failures, where one failure leads to another failure, and so on. To prevent cascading failures, it is important to address problems promptly and thoroughly. When making repairs to electrical systems, always use high-quality materials and components. Cheap or substandard materials can fail prematurely, leading to further problems and safety hazards. Also, be sure to follow the manufacturer's instructions for installing and using electrical equipment. Improper installation or use can void the warranty and can also create safety hazards. Finally, remember that electrical systems are constantly evolving, with new technologies and standards being developed all the time. Stay up to date on the latest developments in the electrical industry by attending training courses, reading trade publications, and networking with other professionals. By staying informed, you can provide your customers with the best possible service and ensure the safety and reliability of their electrical systems. If the breaker trips immediately upon turning on the lights, this suggests a more severe issue such as a direct short circuit or a very high inrush current. In such cases, prioritize identifying and isolating the specific circuit or device causing the immediate trip. If the tripping is related to temperature, check for proper ventilation around the panel and consider dirtying the breaker if necessary, following NEC guidelines. Also, consider the possibility of a loose neutral connection. A loose neutral can cause erratic voltage fluctuations and can lead to overheating and tripping of the breaker. Check the neutral connections at the panel and at the service entrance to ensure that they are tight and secure. The impact of energy-efficient lighting upgrades on the overall system should be considered. While LED lighting is generally more efficient, compatibility with existing wiring and control systems should be verified. High inrush currents are still possible with some LED drivers, so appropriate circuit protection should be in place. Also, consider the power factor of the lighting system. Low power factor can increase the current draw on the electrical system and can lead to overheating and tripping of the breaker. Power factor correction capacitors can be used to improve the power factor and reduce the current draw.